I want to appreciate everyone's attendance today at our second run of our hands-on lab focusing on Upsolver SQL Lake. Really, the goal of today's session is to walk all of you through how to build pipelines on the Upsolver SQL Lake platform, specifically pipelines geared around data in motion or streaming data that you might have that you need to work with. My name is Jason Hall. I'm a senior solutions architect at Upsolver. And again, really happy to be presenting this content for you today. So really the objective of today's session is I want all of you folks to walk away with a good understanding of the SQL Lake platform, specifically what makes it unique and valuable to our customers, what the architecture of SQL Lake is and all the different components that you'll use to build out pipelines, and the user interface itself. And we're going to do all of that by walking through, and hopefully you will all be following along with me, a few end-to-end pipeline creations. Okay, all of these data pipelines are going to involve ingesting data from S3, performing transformations on that data, and then populating a data lake with our transformed data that can be queried using Athena. So each of our pipelines are going to kind of take that workflow of reading data from S3 and writing into a data lake. At the very end of this session, we'll also walk you through how you can connect to your own data. The workshop today is going to be using some sample data that we provide to you, but we would very much encourage you to connect to your own data sources, be it S3, Kinesis streams, Kafka topics, and I'll give you some insight in how you can do that in the SQL Lake deployment. At the very end of today's sessions, really to help encourage everyone to follow along, we'll also be doing a giveaway for anyone that does complete the workshop exercises today. So at the end of the workshop, we're going to be asking a very simple question, but you will need to complete the exercises in order to be able to answer that question. And for anyone that answers it, in other words, for anyone who completes the workshop, we'll be sending you something, depending on what country you're in. We'll kind of determine what we can send you, but we'll be sending you a little thank you gift for following along in the workshop today. Right. So with that said, let's go ahead and jump in. So first of all, what are we working with today? It's a platform at Upsolver we call SQL Lake. And really the core concept or the key core value proposition of SQL Lake is to really help data professionals, data engineers, data producers, data consumers, build streaming data pipelines at scale. And you're going to see the way that we build and manage pipelines in SQL Lake is through writing SQL queries. We have a tagline we like to use here: write a query, get a pipeline. And that's really as simple as it is in SQL Lake. So we're going to be doing that as we go through the exercises today. And you'll see as you build out these pipelines using SQL, Upsolver SQL Lake is going to handle all of the scheduling, all of the orchestration, all of the optimization, and really handle the continuous operation of those streaming data pipelines. We're going to be working on a fairly simple data set today that happens to be on S3. It is data in motion, and otherwise it's very frequently updated S3 data. But really one of the core values of SQL Lake is its ability to handle both batch and streaming data at scale in a single platform. So our exercises today are fairly simple, just a single source of data. But as use cases get more complex and involve combining data sources, maybe combining batch and stream data, you'll see, and we'll hopefully be able to show you today how we can make that process much easier in a single SQL Lake platform. And then lastly, we're not going to really talk about pricing today, but just know that this is a very cost-effective platform. We have a very predictable and very efficient pricing model that our customers can leverage. So hopefully cost doesn't get in the way of being able to take advantage of the platform that we're using. Right. So logistically, as we go through the exercises today, I recommend that if you have a dual monitor setup, try and put the Zoom slide presentation on one monitor in full screen, and then have a browser open on your other screen. I'm going to be guiding you through some slides, walking you through some exercises, and I think it'll be helpful to be able to reference the slides and your SQL Lake interface without having to minimize and maximize and do that whole dance. If you only have one monitor, that's fine. But if you do have a dual monitor setup, I think it'll be best to have Zoom on one screen and a browser on the other. Try and follow along as best as you can and minimize distractions. We're going to go fairly quickly through this workshop today. We've got 3 pipelines to get through in a fairly short amount of time. Unfortunately, if you do fall behind, it's going to be a bit tricky to catch up. So try your best if you can to kind of follow along and minimize distractions as much as possible. I am going to send a copy of the slide deck out, and I'll actually do that right now as I'm thinking of it. I'd rather you follow along in the Zoom meeting if possible, but if you do get distracted, if you do have to leave early and want to follow along with the slides, I have made those available, and all of you can go ahead and download the slides so you can reference anything that we discuss after the session. It's now in the chat. You should all have access to that. And lastly, if you do get stuck, if you have a question you need to ask, or if something's not working as you expect it to, or you want to interact with us in any way, we've muted all of the phone lines for audio quality reasons, but you can take advantage of Zoom itself. There's a chat function you can use. There's a Q&A function if you have questions. And if you have a specific question, take advantage of the raise hand button in Zoom. There's a reactions interface. I've got a few of my team members helping me moderate this workshop today. So if any of them notice a hand raised, they'll invite you to chat one-on-one and hopefully answer any questions that you might have. If you do get stuck after the session, or if something happens after we wrap up for today and you want to reach out, feel free to email me. My email address is down there on the bottom of the screen, Jason Hall at Upsolver.com. And then you can also join our Slack community. The Slack community is a public community. Any of you can go ahead and access that, join a number of channels, ask questions, and interact with the community at large. Okay. So with that said, let's go ahead and get started. I am going to send along the sign up link to SQLake, and that's the first part of the lab itself, is getting you all signed up. So I will send this in the chat. It's a pretty simple URL for those of you that just want to type it in. But if you access the SQLake sign up page, you can go ahead and create an account. All you need is an email address and password, no credit card required. There's no billing component, just an email address and a password will get you in. Now, for those of you that may already be Upsolver users, SQLake is a new platform that we've released. But if you are an existing Upsolver user, I do recommend that you create a new account to go through this workshop with. Mainly because these new accounts are what's going to have access to the sample data that we're running these exercises through. So if you are an existing Upsolver user, go ahead to app.upsolver.com and log yourself out, and then jump back into SQLake and sign up with a new email address. You can either use a personal email address, or you can use this plus syntax by adding a plus SQLake to the end of your username. And that'll get you in with a fresh account. All right, so that's really first step. Go ahead, get signed up with SQLake. Again, email address, password, click sign up, and you should be in straight away. Right. Now, when you do log in for the first time, there are a few onboarding questions. Some of you may already be working your way through those. Feel free to answer those as much as you'd like. You can click next to get through them. Just a few questions about the platforms that you work with, the data sources that you have, and the type of data that you work with. That can kind of help us understand a bit more about you as a customer, as a potential user, and serve up specific content that might be relevant. Okay. Now, after you get through those onboarding questions, you should eventually get to the screen that you're seeing, a screenshot that you see in the slides here. You'll see a bit more on the screen, but you'll see this image that says, let's create your first pipeline. And you can click on the use sample data to browse through some of our sample worksheets. So hopefully those of you have gotten signed in and you've filled out the onboarding questionnaire and gotten to the screenshot that you see here to use sample data. And specifically, we're going to be looking through this Amazon S3 to Athena template. So with the Amazon S3 to Athena template open, I'll just talk you through the sample data that we're going to be working with. Specifically, this is some e-commerce data, and specifically it's in a JSON file format. Okay, this is recorded in a streaming fashion into that S3 bucket. So as users interact with a fictional e-commerce site, their order information is stored in JSON and placed into an S3 bucket. This could just as easily be on a Kafka topic or Kinesis stream, and it would function very similarly in SQLite, but in our case, it happens to be coming from S3. And you can see some sample JSON there in the screenshots. So it's pretty deeply nested. There's some nested JSON, there's some arrays, there's a variety of data types. Should give us a good understanding on some potential transformations that we can perform. And really, that's what we're being asked. So all of us that are going through this workshop today, we're kind of taking on the role of a data engineer. We're being asked to ingest this data into a data lake and then transform it in a variety of ways to create data products for end users, maybe for analysts, maybe for downstream processes, data scientists, whoever that consumer might be. It's really our job as data engineers to ingest this raw JSON and then transform it to build out our data product sets. Now, if you have the worksheet open, the first worksheet that you open, it's going to have some helpful highlighting to kind of guide you through how to work with it. If you've already used SQLite before, you may not have the highlighting, but you should actually see on line 13 in the first worksheet, you have the first SQL that we're going to run. There's some comments above that. You're welcome to read it if you'd like. But you can jump to line 13 and go ahead and execute the first command. You'll see it's a SQL command, and this is the command that we're going to use to connect to our S3 bucket, right? Again, this is where our sample data is. It's in S3. And if we click on that little triangle to the left-hand side of line number 13, it'll go ahead and create the connection for us. There's not much to this command, just give it a name. Connect with an AWS role and external ID. We're setting it to read only. And with that one SQL statement, we can create a connection to S3 that we can read data from. Okay. Again, you can click that little triangle button to the left-hand side of the line number. If you prefer keyboard shortcuts, you can also run either Command plus Enter on Mac or Control plus Enter on Windows, and it'll run the statement wherever your active cursor is. So you can put your cursor in the block, hit Command Enter or Control Enter, and it'll go ahead and execute the query for you. Right. So that's really step one. Let's create a connection to S3 that we can read data from. Right. Now, if we go ahead and continue, and I'm sorry, I always have to remember in Zoom how to get the annotation back. There we go. You'll see every time you run a statement in a SQLite worksheet, it's going to provide feedback down on the bottom of the screen. So specifically in this case, the feedback will tell you whether or not the connection was created successfully. And then it'll also guide you through some next steps. All right. So in our case, we've created a successful connection, and it's telling us to now run a create table statement to create a location, in this case, a table for our raw data. So every time you run something in SQLite, just look down at the bottom of the screen and you'll get feedback about what you've executed. Hopefully a success message. If there are any errors, that's where you'll see the errors that are presented. Okay. Now on the next screen here, this is where we can browse through the connection that we've created. If you look over on the left-hand side of the SQLite interface, you'll see a section of catalogs. Now, these are where you're going to view all the different components that make up your pipelines. Now, every user in SQLite gets a default glue catalog connection. That's there. It's implied by the name by default. Everyone's going to get a connection to system tables. We're not really going to work with those system tables much in today's lab, but just contain useful metadata and performance data about how the system is operating. And then you'll see the new connection that you've created, specifically the Upsolver S3 samples connection with the samples bucket underneath it. And you'll see you can browse through that bucket to see all the folders that are underneath it. Specifically today, we're going to be working with this orders data. Okay. Now, if we keep going, you can scroll down to step 2 in your worksheet. Right? Step 2 in the worksheet is, let me bring up my annotation again here, is to create a table that we're going to ingest data into. Now, the create table definition here is very simple. All we have to do is give it a name. Right? And you'll see the 3-part naming convention here. You've got your catalog name by default, in other words, default glue catalog. You've got a database. Every user in SQL Lake was given a database. So your database will be a little different than mine, but you all have a database that you'll be creating tables in. It should be already defined. You don't have to modify any of the SQL here. And then you have a table name, and we're going to call this table orders raw data. The empty parentheses here shows you that we don't have to define any schema for this table, right? We're just going to define it with an empty schema, and we'll be building out the schema automatically as we read data off of the S3 source. The only other thing we will do here is we will partition this data by event date. This $sign here indicates it's a system column. This is always going to be a part of our source data, so it's a good option for partitioning the data that we're reading off of S3, right? So again, if you click your cursor in there and click the run button, we can generate that table. Again, you'll see the feedback down at the bottom of the screen that hopefully it was created successfully with some guidance to now run a create job statement to ingest data in to that table that we've created, right? Now, I did want to highlight a few things. You might have noticed in the feedback some mention of a managed and optimized table. What does that mean? At its basis, managed means that Upsolver is going to be managing the table definition for you, right? So we automatically create glue catalog entries for the tables that that SQL Lake is managing for you, and we automatically manage that schema, right? Remember, you didn't define any hard-coded schema in the table definition. So as fields show up in the source data, the schema will be automatically defined in that managed data table. And as the schema evolves, there's various things that SQL Lake does automatically to maintain that evolving schema of your source data. Right? We are also managing statistics for all of the data that gets ingested. And you'll see these as we go through the exercise. We're going to know how dense the fields are in the source data, what the data types are, what the distribution of top values, what the cardinality of each field is, and all of that gets defined automatically as we read data. And then we've already talked about system columns. We automatically create system fields with the source data that you can look at to inspect the ingested data and also use it downstream in transformation. So we manage all of that for you within your Glue catalog. If you go down here to optimize, this means that we are also optimizing each table automatically and continuously within SQL Lake. We've already talked about a bit about partitioning. Because we can partition by system columns, SQL Lake can manage that partitioning for you automatically. We are also continuously compacting the data. You know, compaction basically means we can take very small files and compact them into larger files, which make querying much more efficient. Right? Event and streaming-based pipelines can often end up with millions and millions of very small files that can make querying very expensive and time-consuming. So we continuously compact that ingested data to make that much more efficient. And then also you can define data retention. The default is to maintain data or retain data indefinitely. But if you want to apply data retention on your tables, you can do that automatically as well. All right. So in other words, you can say, you know, let's keep data for 30 days, automatically delete anything that's older than that. Right. So, and again, all of these things happen automatically in SQL Lake. Once you create a table, it's managed and optimized for you. Okay. So let me get out of annotation here. So we've now got a table. You can browse through it in your catalog. Some of you may already have done, but you'll notice by default, all you have are those system columns. So if you expand open the orders raw data table inside of your database, you'll see the system column, since all we've done is define effectively the empty shell of a table that we're going to load data into. Right. Now, step 3 here is where we load data or create what we refer to as an ingestion job, or Upsolver refers to this as a copy from job. And you can see the syntax here is pretty straightforward. Go ahead and create this in your lab right now. Just again, create it. You can let it start running in the background. We're going to create a job and give it a name. We're going to be looking for JSON content, and we're copying from the S3 samples connection that we created. There was a question earlier that I saw about our connections specific to a session, or are they created once and then reused? And it's the latter. Once you create a connection, it can be used for as many processes as you'd like, right? So we're creating a job. We're looking for JSON inside of this Upsolver samples bucket, specifically a folder called orders. and we're loading that data into the raw data table that we defined. All right, so that's as simple as a copy from job is. Just create it, and now we'll start loading data in to your staging table. Now, if you look at the feedback here, it'll tell you initially that the table was created. If you do have any syntax errors, you can correct them here. But with the table created, it will then start loading data into it. All right, and this first initial comment you'll see here is that it started to read data. You'll start to see schema columns defined, and then as data gets ingested, you'll see an updated record inside of this feedback telling you that data has arrived and started to be loaded into that staging table itself. All right. We kind of look at the architecture of what's happening behind the scenes here. Again, we've run 3 SQL commands so far. The first command was create a connection from S3. The second command was to create the staging table. And then the third command was to create the copy from job that reads from S3 minute by minute and then loads data into our staging table in a continuous fashion. All right, so real streaming, continuous minute by minute loading of raw data into our staging table. Right. Now that that's done, I'm guessing most of you now have started to see data showing up in your staging table. You can know that in a few different ways, but specifically, if you look at the execution results tab here, you should see that the table is ready with initial data. And it's actually telling you that you can query it using a select statement if you'd like. But before we go and query our staging table, I just wanted to show you some of the statistics that we create. If you look over in your catalog on the left-hand side of the screen, you'll see again your orders raw data table. There's a little refresh button next to it. You may have to hit refresh if it hasn't auto-refreshed yet. But once you do, you'll see a list of columns that come from our source data. Right? Again, each of these columns was automatically identified as we read that data, that raw JSON from the S3 bucket that we're reading data from. If you click on the table name, so click on the table name itself, you'll see this information card show up down at the bottom of the screen. That's kind of a summary of details that we have for that table. Specifically, you can see event graphs that show event collection over time. We have only been running this for a minute or so, so it won't be overly interesting. You'll see we found 35 fields in our source data. One looks like a key column. 6 of them are nested into an array. And we can see some field statistics down at the bottom. If you click on this little diagonal double-sided arrow, it will expand the schema statistics, and you'll be able to see much more data in a larger screen. Specifically, you can see, for example, each field within that raw data table, the data type that was automatically inferred from the source data. Density, this is how often that source field shows up in the source JSON. Some of the top values contained, whether it looks like a key column, how many distinct values we have, whether it's an array, and then when it was first and last seen within the source data. Okay. In your example, we've only been running this copy from job for a few minutes, so you're going to see first seen and last seen almost always be the same, right? But if the schema evolves, right, there was actually a question that came through about what if fields are different between different JSON records, right? Or what if a column name changes? Or what if the business starts adding new fields to some source JSON that we've been ingesting for the last 6 months? You can start to identify those things in the first seen, last seen metrics, right? For example, maybe all of our fields we first saw 35 minutes ago, but some fields we just last saw 30 minutes ago, right? That's kind of a bad example because it's a short-term period of time. But if we last saw a specific field days ago or weeks ago, it's a good indication that that field is no longer being included in our source JSON, right? Or maybe counter, we first saw some data a few days ago where the rest of our fields we've been seeing for 6 months, right? This is now a new field, or maybe the field name changed. And so that could indicate that we've got some schema evolution in our source data, but these values can be really helpful for understanding whether or not that's the case. If a field name no longer shows up, we of course need to exclude it from our transformations. If a field name has started showing up, maybe we now need to include it. All right, and you can use density too to help with that too. Maybe we've got 2 different fields that look to be the same, each of which fit in 50% of our data. right? Now, in addition to kind of browsing the table statistics, you can also click on an individual field. For example, click through the nested customer column. Click into customer, open up address. You can click on something like state. And then over on the right, you'll get some more detail about that specific field. All right, it's in 100% of our events. We've seen in my screenshot, you've seen probably a little bit less, but 756,000 total values, 47 distinct values. And then you can see a distribution of top values, right? In my example, NY as a state is the top value showing up in roughly 10% of the JSON events. So when, if you think back to when we said we created optimized and managed tables for you, this is part of what we're referring to, right? All of this schema is automatically defined on read, and we maintain all of these statistics about that data as we read it into our staging tables. Right. Now, some of you may have already gotten this far, but if you want to scroll to step 4, you can also query our raw data table. Right. So if you want to actually inspect more deeply what that raw data looks like, you can just run queries against it. SQLake includes a Amazon Athena interface so that you can directly query all of your SQLake tables. All right. And if you run a select statement in a SQLake worksheet, you'll see the results show up down below. This is a simple select star with a limit of 10, so we're returning 10 rows, but this is pretty, familiar SQL that you can run, again, using Athena, but against a SQLake table and see the results down at the bottom. Really helpful for inspecting that data that we've read off of S3 and now staged in one of our data lake tables. Right. There are a few nice capabilities of the result set UI. It's pretty intuitive for those of you that have used result sets before in various interfaces, but specifically you will see, different tabs containing all the different things that you've done as you build out your pipelines and worksheets. The result set columns can be sorted. You've got buttons over here on the right to minimize or close out of all of your result sets. There's also a search if you're looking for a particular piece of data within a result set, and also a download button, which can be really useful if you want to download the result set to CSV, so you can maybe pass it off to someone or further inspect the data. You'll also see very large result sets are going to be broken into pages. There's a limit 10 on the Athena query in your worksheet, so you'll at most have 2 pages. But if you want to see a larger result set, you can change or remove the limit, and you'll see each page of result set separated out by tabs. So continuing, we've got a few more steps in this pipeline. Step 5, if you scroll down, is to create a table to write our transform data into, right? So far, what we've done, just to kind of summarize, we've read data from S3 and we've copied it into our orders raw data table. Now we're going to be creating a transformation to transform the raw data and write it into a separate table, a data app or a data product, as is often described. Right. This create table statement is going to be very similar to the table that we already created. The only real difference, other than the table name here, is that we are defining one schema column, specifically a date column called partition date, and we're partitioning by that column. All right. So you can define other schema columns if needed, and we will in additional pipelines. But in this case, we're just going to create a partition field in our target table. Right. Now, with that created, we're going to go to the transformation job itself. Now, the transformation job is a little long to include in a slide, so I'm actually going to exit out of a slide here and step through my worksheet where we can follow along. So if you look here, we should all be kind of at this point in the exercise right now, step 6. And specifically, you'll see here a create job syntax. All right. Now, the job that we created earlier was a copy from job. Right, that copies raw data from some source into a target table, right? In our case, it was that raw data table. Now what we're going to be doing is something called a insert into job, right? And the insert into job effectively does that. Reads some data and inserts it into the data transformation table. There's a few parameters at the top of the job here. We are going to start reading from the beginning of our source data, right? So this is going to ingest and transform historical data from our source table. We could also specify now here if we only wanted this transformation to apply from current, so from right now forward. You can also put timestamps in here if you want this to apply to a specific timestamp. Add missing columns here is where even if the columns were not identified in the table creation, right? Remember, we only identified the partition date field. This tells this job to add additional columns as defined by the transformation. If you want your table schema to be fixed and rigid, you could set this to false, and then new columns will not be added. And we're going to run this transformation job minute by minute. So on a 1 minute interval, you'll have near real-time freshness on the transformation side. Right. Now, if you scroll down here, the transformation is defined using this SQL, right? And I'll ask you to ask, why don't you go ahead and run this in your lab? I'll do the same here. Sorry, didn't create my table yet. There we go, and I'll run it just to give it a bit of time to start our transformation as I explain it. But notice that the first part of this create job is just really properties and parameters. And then you have this SQL that defines how to apply your transformation logic. Right? Again, pretty simple select statement. We've got a couple fields that we're simply aliasing to different field names. We're applying an MD5 hash to a customer.email nested field in our source data. If we look at our raw data table here, you've got customer email. We might not want to include the actual email address in our output table, so we'll just apply an MD5 hash to it, so it's hashed. Now, customer name, notice this field does not show up in my raw data table, right? And this is a calculated field that we're building as a part of the transformation logic, right? So for example, you'll see this let command under the from clause, right? The from is pretty straightforward, reading from the raw data table, but let here allows us to create a calculated field that we can then pass into our transformation. We're creating a field called customer name, and we're creating that by doing a string concatenation of the first name, the double pipe here is string concat, to a space, concatenated to the last name. Right, so pretty simple calculation, simple string concatenation, but we're building a customer name field off of the first name and last name field. And then we're inserting that in the select clause of our SQL. We're adding net total, so we have a numeric value that we can include. And then we're casting commit time, which is a system column of our source data, our raw data table. And we're going to be using that as the partition date field that we partitioned our transform table by. Okay. We can do filtered result sets using a simple where clause. So maybe we don't need all of our source data in this particular transformation. So just a where order type equals shipping. We'll filter the result set and only include relative records. Right. And then finally, we have an and commit time between run start time and run end time. This is a streaming job that runs minute by minute. This just simply tells the job to process all data that arrived in our raw data table between when this job started and when this job finished, right? So minute by minute, basically transform all of the staging data that occurred within that minute. You can manipulate those if you want your transformation to apply over different time ranges. Right? Now, as you build out a transformation, we do offer preview. This is really helpful. This code was given to you so we can be pretty assured that it's working as intended. But as you develop a transformation, you might want to see what it looks like. To the left-hand side of the run button in a worksheet, you can run a preview. And this will take a sampling of your raw data and run it through the transformation logic and show you the output, right? So for example, you'll see in the preview tab, we've taken 236 rows within our sample, and here is what the transformation looks like. Here's our order ID. Here you can see the hashed customer email address. Here you can see the calculated customer name. So this is really helpful for debugging your transformation without actually having to go and run any jobs or even create any jobs. Preview it, get it to a point that you're happy with it, and then create the job to have it run continuously. Right. Now, with your pipeline running, you can go to step 7. And again, just like we query the raw data table, we can query the transformed data table and see what our transformed data looks like, right? Looks just like the preview, just now it's the actual data lake table. This job that we created is now transforming data minute by minute into that transformed data table that we can query using Athena or whatever your favorite query engine is, Dremio, Starburst, anything that can query a data lake with a glue catalog metastore. Or we could use this to maybe populate like a quick site dashboard if this is more of an analytics use case. So let me jump back to the slides here. I'm actually going to skip this since it's pretty self-explanatory. But you should now have your first pipeline complete, right? If this is the first pipeline you've built in SQL Lake, you'll see a celebration once it's finished, kind of summarizing what exactly you've done. Right? We spent about 20 minutes in building that pipeline, more because I was explaining in a lot of detail about what happened. But when you actually think about what we did, we ran about 5 SQL statements, right? One to create a connection that we can reuse as many times as possible. We created source and target tables, and then we created 2 jobs, a data ingestion job and a data transformation job. And with those 5 SQL statements, we now have a fully operational pipeline running in a streaming fashion, minute by minute, reading data from S3, ingesting it into the data lake, transforming it, and then writing it into a data product table. So that's our first pipeline. So I'm going to push out that poll again, hoping everybody was able to follow along, given that we spent a lot of time explaining things, but I just pushed out the poll. Just want to make sure that everyone's kind of followed along with the first pipeline that we've built out. Right. Got most everybody up. There are a few people that do say they need more time. If you do have a specific question or if something's not working right, again, feel free to send a Q&A in Zoom or raise your hand using Zoom reactions. And one of our SAs will reach out directly through chat and try to help you along. Okay, so let me go ahead and end that poll. There's a question there about where did you enter source and target info? So if you go back and think about the pipeline, right? And I'll actually do that just real quick because I think it is important. The source of this pipeline was the S3 data that we're reading data from, right? So we created a connection to S3 to read data from, and then a copy from job to copy data from S3 into this raw data table, right? We then created, there's the copy from job. We then created a target table. Here it is, this transform data table, and then a data transformation job to read data from the raw table into the target table. And all of that was defined in the transformation job itself, right? If we look at this transformation job, we created the job. It's an insert into, and this is where we defined the target table. And then in our select, we're selecting from our source table, right? So we build the source and target tables, we populate them through copy from jobs, and then our transformation select is where we define where this data is reading from. I did see a question, I think it was answered by one of my moderators earlier, but I think it's helpful for everyone to see too. Can you use the same source for multiple downstream transformations? Absolutely. And that's what actually we're going to be doing through the rest of these exercises. Right. So let me get back into slides real quick. Hopefully everybody's kind of caught up. If you look at the very top of the SQL Lake worksheet that you're in, you'll see a few controls. You'll see another run button, preview button if you want to run things within your worksheet. You'll also see SQL snippets, right? So those are just code samples that you can include in worksheets that you're building yourselves. You've also got the worksheet name that we've been working with. If you hit the drop down, you can rename it or copy it or download the SQL offline. And then you've got this left-hand back arrow that will bring you back to a worksheet list. All right, go ahead and click on that back arrow to get back to the worksheet list. All right, right here. And we're now going to launch the second pipeline, which is performing aggregations. Right, there was a question that was asked earlier, just saw about how to aggregate. So we'll walk you through this pipeline here. In the upper right-hand corner of the SQL Lake homepage, you'll see a button to create a new worksheet from a template, and look for the template with sample data called aggregating events. Right? Make sure it has sample data in the name of the template, because that's going to work off of the sample data that we've created. Right? Once you have that template open, then you will see, sorry, let me clear out the annotation here. You can skip ahead to step 5 and 6, right? Because we've already created a connection to S3, step 1. We've already created a raw data table, step 2. We've already created a copy from job, right? Step 3. We've already inspected the raw data. So we can jump straight to step 4 to reuse that ingested data for a different transformation, right? So if you run step 5 here, this is the exact, very similar create table statement to what we ran earlier, with one exception that we are defining a primary key column, right? So inside the aggregated data definition, we've got one field, we're calling it customer address city as a string, and we're defining a primary key on that column. And the primary key is going to be important because this is an aggregated use case, right? With the table created, and again, I highlighted here primary key because this aggregation is going to upsert into our data lake table by the primary key, right? Remember, this job is going to run on a given interval. Let's assume minute by minute. We're creating aggregations on our source data and writing it into an aggregated output. And we may want to have that table have its aggregations updated every time a new aggregation is calculated. So we do that by defining a primary key on our table. And then when our job writes into an existing primary key, it will update the aggregation. If it's a new primary key, then it'll append a new record to our output table. Right? Now, if you look at the aggregation job in this pipeline, or sorry, I should say the transformation job, the first few lines here are exactly the same, right? No difference at all. If you look at the select statement, this is where you define your aggregation, right? So for example, we are reading the primary key column came from customer address city, and we're aliasing that into our output. So customer address city, that's our primary key column. And we're using that in the group by of our select, right? So aggregated use cases in SQL Lake are really just SQL statements with group bys, right? We are then applying aggregate function calls here. So the sum of the net total field as total revenue and the count of order ID as the number of orders, right? So just like you would run an aggregated SQL in whatever database you might be running or familiar with running them in, we're now writing an aggregate SQL to use as a transformation job. And we're going to be inserting that into our aggregated data table, right? And so that's how you can do aggregated pipelines in SQL Lake. Let me actually escape out of here. And I will just simply show you. Some of you may have already gotten to the end here, but let me open by template. Look at our aggregating events template. Again, we can skip ahead to step 5 to create our output table and then create our aggregation job, right? And so, yes, this is one way that we can handle upserts in an aggregated use case, right? It's just simply by the primary key definition on our aggregated data table, grouping by that primary key, including that primary key in our select, and then specifying whatever aggregate functions we want, right? So that's effectively how we can create an aggregated output. This will take a minute or so to populate the output table. Once this is finished, I'm guessing it will be finished momentarily. You can go ahead and query your output, your aggregated data table to see the results of your transformation. So that's an aggregate use case and also an upsert use case into a data lake table. Every time this transformation runs, again, if it creates a new aggregation for the city as the primary key, it will insert that, or I should say upsert that into our data lake table. Now, while this runs, some of you are probably further ahead than I am. If you go back, I want to show you, oh, there we go. Sure enough, once I started talking, it finished. So if you query your output here, you'll see the aggregate results of our aggregated data table. So you've got a city here with a number of orders and total revenue based on aggregate function calls to our source data. Okay. Now, if we click back, we've been entirely working in worksheets here in this lab exercise. There's another section of the Upsolver UI here for jobs, right? We've created 3 different jobs as we've built out 2 pipelines, and we can now see the status of each of those jobs within the job section of the UI. You'll see 3 jobs, their status, if there's any delay in processing, if there are any errors, how many events those jobs have processed. We can also drill into those jobs to see more detail and historical data about job processing. So again, if you want to kind of see some more detail about the jobs that you've created, we do have job monitoring built into SQL Lake. You can see this load raw data from S3 job has processed almost 9,000 events at a rate of roughly 2 events per second. There's no delay, and you can see some graphs showing event processing delays and utilization metrics for the pipeline jobs that you've built out. So the last pipeline that we're going to build now is how to work with nested JSON and array fields. Right? So again, go back to your home screen in SQL Lake, create a new worksheet, just as we have already, and you can search for workshop, or you can look at the templates with sample data and find one called workshop 1.3, working with nested JSON and arrays. Right? Searching for it, if it doesn't show up, obviously should hopefully find it for you. Again, it's called Workshop 1.3, working with nested JSON and arrays. And specifically, let me go straight into that worksheet with you. New from template, sample data, nested JSON and arrays. Okay, so if we scroll through again, we can skip some of these first few steps in the worksheet. We already have the S3 connection created. We've already ingested our raw data. But if you run a select against that raw data table here in line 40, you'll again notice that you've got a customer field, which includes lots of nested JSON. And you've also got a data field here, which is an array. It's actually an array of nested JSON. If you run the SQL here on line 41, you'll see that Athena does allow you to extract the nested JSON fields. Those aren't too difficult to work with. But this items array is much more difficult to work with in transformations, right? There's no real way to extract nested JSON from within an array of, in this case, items, right? So that's what this pipeline is going to show you how to accommodate. If we scroll down, we're going to define a table to output our data to. Again, very similar create table statement to what we've seen already. The only real difference is that we now have a multi-part primary key or a composite key, all right? We're going to identify a primary key by both the order ID and the item ID. The item ID is contained within the items array. So we're going to extract the item ID out of the nested array and then flatten it so that we get one row in our flattened table for each order ID and item ID. We might do this just for simple visibility into item behaviors, but also we might then want to aggregate sales by some item within the nested array. Right? And you'll see the transformation job on how you do that. Right, pretty straightforward. First few lines here, no different than what we've already seen. We then have a select statement here, which simply extracts and aliases nested JSON fields. Right, so extracting nested JSON into separate columns is very simple. Just reference the nested syntax here, customer.firstname, and alias it to whatever separate column you want. Within the items array, that's also fairly simple. We can take the items array and pull out each nested field and then extract that into its own column, right? What makes this work, really, where the magic happens, is not necessarily the syntax here. It's that we wrap the entire select statement in this unnest command, which tells the transformation to do exactly that, right? Extract an unnest JSON into separate columns and extract nested JSON within the items array and flatten it into separate rows, right? All that happens through the use of this unnest command that surrounds your SQL query. The rest of this query, pretty straightforward. We've got a simple inline function call just to standardize the order type. And we are fixing the country definition here using this let command. If you actually look at the source data and we look at customer, address, country, you'll see we've got US represented two different ways. This will standardize that. And if we look at order type, you'll notice mixed case, right? Both upper and lower case. So this will fix that, right? So this, you can kind of correct some source data problems here using the same transformation, okay? Like with the for, if you want to preview the data to see what it will look like, go ahead and preview. And sure enough, you can now see the order ID and item ID has been flattened in this transformation, right? Specifically, you'll now see multiple copies of the same order ID, but if we scroll to the right here, you can see item ID is now what makes up the multi-part primary key, and we've taken the item ID out of the array, taken that nested field out of the array and flattened it into separate rows within our transformation, right? And so now that the data is flattened, we can query it, using Athena, just like we've seen so far. We've gotten our flattened data set. And then we can also use this in additional transformations, maybe to aggregate our result set by some field that was nested inside of that items array, right? For example, we might want to aggregate by item ID, or aggregate item performance by city, or maybe even do some additional transformation on this category string, right? Maybe split this category string and then aggregate on top of that. But we can now do that because we've extracted and flattened the array. Somebody noticed the category was not unnested, and that's a good notice. This is actually not technically nested. It's just the way that our source data was populated was that it's a string. So categories are defined by a string delimited by the pipe. So that would be actually an interesting homework assignment for the audience. If you want to play around with how to work with that, you can use a variety of function calls. We provide a split function that can split the items category by the pipe delimiter. You'll then get an array of categories, and then you can flatten that array of categories in an unnest output. So good noticing there, and that would be a good use case maybe to tackle if you want a homework assignment. So with that said, I'll leave you with kind of what to do next, right? So first of all, if anyone needs further help, right? So we do have help built into the product. You'll see a little question mark in the lower right-hand corner of the screen. If you click on that, there's a few different ways to interact with our support. We've got searchable documentation, which has all of our SQL syntax and all of our function calls fully documented. You can contact support. And we have both live support through chat during business hours, as well as the ability to open up tickets if things are occurring outside of business hours. And then we also have a direct link to our Slack community for those of you that might want to interact with us on Slack. Just to kind of summarize, right? So we've now built 3 pipelines. Right? All 3 pipelines followed a very similar workflow, reading data from S3 once and then creating several different data products using different types of transformations using SQL. Now, keep an eye out. I actually have the date wrong here, but on December 15th, you'll all get an invite. We're going to do a future workshop that focuses on some additional exercises, more advanced transformations, how to work with dates and times, how to do advanced aggregations, and also how to work with multiple data sources, right? Both unions and joins of multiple data sources in your ETL logic, right? And again, if anybody wants to maybe get a little teaser of those future exercises, take a look at the net total column of the source data in that raw data table, right? So, and that net total table is wrong. It's got some inconsistency to it. I'll just kind of leave you at that, and then maybe browse through the source data and think of if you have any ways that you might be able to address that through a transformation. Right. How to connect to your own data. Some of you might now want, that somebody had actually asked a question, can you connect to your own glue catalog? And the answer is absolutely. All right. If you look for a template in the template catalog called data ingestion, you'll see a whole bunch of examples on how to make your own connections within SQL Lake. Connections to S3, connections to Kinesis, connections to Kafka. They all involve simply pasting in your own connection-specific properties to connect to your own data sources. In general, for AWS connections, you can either use access keys and secret keys, or you can use AWS roles, depending on how your roles are defined. If it's something like Kafka or Snowflake, or some other data connection, you can see different parameters, host names, ports, usernames, and passwords that you can fill in. And yes, if you connect to your own glue catalogs, you'll see examples there. Right? So again, mark your calendar for December 15th. I have the proper date here. We'll be doing a second part of this workshop. So thanks again for everyone's attendance today. Hope this was informational, and I look forward to the next one.